All right, so today kind of use it as a kind of a not relaxation day, but more of kind of a wind down day. Mostly just kind of stretched, did a few like body weight stuff. So I did a few push ups, did some just like farmer's carry. So just mostly just a lot of like upkeep, I guess. I didn't do a whole lot today. Um, Life's been a bit crazy, everything's kind of winding down for the semester, but yeah, it was okay. Just kind of did a maintenance day. But today, continuing with adaptations to endurance training, talk about how our muscles kind of get the idea across that they're needing help. First way they're going to do this is through mechanical stimuli. So obviously muscles have a couple different ways to detect this, but the main two are Golgi tendons, which are going to detect tension in the muscle, and then muscle spindles, which are going to be stretch in the muscle. So kind of where it is. Next one's going to be calcium. This is going to be a big one. If we're constantly seeing calcium flood our sarcomere, which is going to happen a lot in marathon runners or cyclists where we're needing rapid contraction over and over and over again. What our bodies will actually do is start leaving calcium out longer instead of uptaking it like right away. So we'll basically just kind of bathe our sarcomere in calcium and let it sit there for way longer than usual. Next one's going to be free radicals. These are just these like unpaired electrons. And so when we see those unpaired electrons, it really does kind of havoc on our system because it just wants to bind with everything, break stuff up. So it's going to increase our stress, increase our inflammation. So in response to that, body's going to increase our anti-inflammatory response. And then lastly, we'll get into more detail, I think, next time, but it's going to be our phosphate ATP levels. So when we're in a basically dire situation, we're taking, usually we go from, ATP down to ADP, and then we, recycle it basically. But when we're in dire need, we actually take that ATP, break into ADP, and then break it down even more into AMP, adenosine monophosphate. And when we're doing that, we really don't want that to happen because we want to be conserving energy as much as possible. So we actually have AMPK, which is going to be what's splicing ADP, making splicing ADP to make AMP. So when we have increased levels of AMP in our system, our body knows, hey, we are like dying right now, like we are going super heavy. So high levels of AMP lead to increases in the mitochondrial biogenesis, like we talked about earlier.